Welcome to the third video of Solid Principle series, Liskov Substitution Principle. We have already discussed single responsibility and open close principle. If you do not have idea about them, you can click on the eye icon and can find them easily. Let us talk about Liskov Substitution Principle now. LSP principle says that if S is a subtype of T, then object of type T in a program may be replaced with object of type S without altering any of the desirable properties of that program. Doesn't seem very hard definition? Let me make it easy for you. Child class should be able to do all that parent class can do. Liskov's substitution principle is something parent has to be substituted by their child, and it is only possible if they can do all that parent can do. Let's assume in our application we have a payment system where we are going to support credit card payment, PayPal payment, and net banking payment. We have a pay method which has the implementation of receiving the payments for any payment type among these three. If we want to pay by credit card, we have to pass the payment type as credit card, and it has its implementation there in the payment method. Same things with the PayPal and the net banking class. To understand Liskov's substitution principle, we have to understand the very fundamental concept of object-oriented programming, that is interface. Interface is a way to achieve abstraction, and abstraction means hide implementation detail and show only required information. To understand what is an interface, let's take a very easy example of remote and TV. To change a channel, we know which button to work, and to increase the volume or decrease the volume, we know which buttons are going to work, but we only know to pressing the button. How remote is doing these things behind the scene is not disclosed. We are not aware about that. That is abstraction. And this is possible because of the interface of remote. Something similar is there in programming using interface. Interface in programming is simply the declaration of the fields and the methods in which a class has to define all of them. In this interface is declaring field and the method. Class 3 has to implement field and the method in its own way. Same things are done by class 1 and class 2. All of them will be defining the method in its own way. Let's take a very good example of the payment system. We have a payment and it has declared two methods. Remember, interface will not have definitions of the methods. It will just have the declaration of the methods. That is, payment class should naturally have the make payment and the get payment status methods, right? So these classes, credit card is implementing the payment, has to define make payment and get payment in its own way, that is using the credit card details. Now if we talk about the payment by PayPal class, it has to define the make payment method with the details of the PayPal account. Same things with the net banking. It has to define the make payment method with the username and the password of the net banking. Let us see the difference between our old and the new design. We have seen in the old design that the classes are not following the same structure, but now while designing them using the object-oriented programming, using interface, all these classes has the same methods but their own implementation. That is the difference, and that will lead us to implement the Liskov substitution principle. Let's see how we can do it further. We have seen this is our new design and the pay method. Pay method accepts the payment object and the amount. If we want to pay by credit card, instead of payment, we are going to pass the object of the credit card payment. The same thing for PayPal and net banking. Now we have to see what is the Liskov substitution principle here. Let us understand that where the substitution is happening. In the pay method, we are expecting payment object, but we are passing the objects of the class which are implementing the payment. This is the Liskov substitution principle. Payment is the parent class here, and credit card, PayPal and net banking classes are the child classes. Now you remember the definition what we talked is child should be able to do all that which parent can do. This method is expecting from the parent to perform make payment and get payment status. But we are passing the childs which are also performing the same tasks because they are implementing make payment and get payment status in their own way. If we also think in this way, that what if we want to support a new payment method tomorrow, then first thing we have to write the class and implement a payment method in that. Apart from that, we don't have to do anything, we just have to call this method. This method do not have any changes for the new class which is going to support the new payment method. This is the Liskov substitution where the childs are substituting the parent. Now let us understand the definition in the very first slide we have seen. If S, credit card payment, net banking payment and PayPal payment is a subtype of payment, then objects of payment in a program may be replaced with object of credit card payment, net banking payment and PayPal payment without altering any of the desirable property of program. That's what we have seen. In the pay method, we are not doing any changes to support a new class or a new payment. This is what LSP principle says. And this is the benefit of LSP principle. If you are learning a lot from here, then why don't you appreciate us in the comments? Like the video and subscribe the channel if you want to continue the learning. We also upload the study material of all of our discussions on LinkedIn channel. Don't forget to follow our LinkedIn channel as well. I will see you in the next video when we will discuss about interface segregation. Till then, have a good time.